puzzling, because you're going to see that its destruction is mysteriously defined as caused by normal office fires. And yet we have evidence to the contrary, which begins our controversy this morning. 47 stories tall. This would be the tallest building in most of our states. It wasn't hit by an airplane. This is a building about 350 feet away from the Twin Towers. Standing here by itself, it survived the destruction of the towers in the morning and came down about 5:20 in the afternoon. We're going to be looking at the evidence for explosive demolition with respect to this building, beginning with, is there a sudden onset of destruction at the base of this building? Well, let's take a look, maybe our first look for many of us, at the destruction of this building, narrated by Dan Rather on CBS that afternoon.
And what you're seeing are high shots. Now, here we're going to show you a videotape of the collapse itself.
Describe that.
Now we go to videotape the collapse of this building.
It's amazing.
Amazing, incredible, pick your word. For the third time today, it's reminiscent of those pictures we've all seen too much on television before, when a building was deliberately destroyed by well-placed dynamite to knock it down.
Well, that's very helpful information from Dan Rather. Indeed, he's using his intuition. That's what we should all be using instead of what we are told by authorities. But let's proceed. Is there a symmetrical, straight-down collapse into the building's footprint? We're looking at 8 or 9 or 10 of the key features of controlled demolition with respect to our research, our deposition today. As you can see, the building is collapsing straight down and symmetrically. In fact, you'll see the main penthouse and screen wall in the center collapsing just a half a second prior to the overall building collapse, indicating all core columns, 24 of them, must have been removed at once. Now, this is in direct contradiction to the official NIST report, which we will be discussing in a moment in more detail. But let's take a look side by side. A known controlled demolition, a series of them on the right, World Trade Center Building 7 on the left. The question is there any similarity? Is there enough similarity to warrant an investigation into the possible use of explosives? Especially since it looks exactly like one, and especially since fire, the official cause of this building's collapse, has never brought down a skyscraper ever. Yet NIST, the National Institute of Standards and Technology, who was tasked by Congress to explain these collapses to the American people, did not even look seriously at the hypothesis of explosives. They focused on fire, normal office fires. These are the fires in these buildings. These are the worst fires that we have photographic or video evidence of. And they are going on until about 3 or 4 o'clock in the afternoon. Yet at 4 o'clock or so, these fires are burned out on the 12th and 13th floor, where NIST cites the initiation of collapse began. And so this indeed could not have been responsible for the thermal expansion in these buildings if they were in fact out an hour prior before. On the left, on the right, you see NIST's fire progression simulation. At 4 o'clock, they cite massive fires at column number 79, the focus of their initiation of collapse. Yet on the left, what you see is the AE 9/11 truth simulation, which shows that those fires, according to the photographs and the videos that we have, show the fires moved on well before the collapse, an hour before the collapse of this building began. So we have a theory by NIST which says that there were massive fires in this northeast section causing thermal expansion of these long span beams that you see at the top, pushing this girder off of its seat on this column 79, which caused floor 13 to fall on 12, 12 on 10, 10 on 9, etc. for 9 floors, leaving this column 79 unbraced for that distance, which then it buckled or bent and broke, allowing a complete vertical collapse inside the building, which then we're told, which caused the collapse of the east penthouse. You'll see all of this in a minute. And then this vertical collapse travels laterally through the building. Here to give us more detail on that theory and the evidence contrary to it is Tony Szamboti, mechanical engineer who spent 26 years doing structural engineering for aircraft, spacecraft, and support equipment. Please welcome Tony Szamboti.
Hold the mic. What do you have to hold? Okay. Yeah, appreciate you having me here. I want to thank the lawyers and other officials here, former officials, for stepping up to this. I think the engineering critiques have been done, and it's time for you guys to get involved. As you can see, I have 26 years of experience in the aerospace industry doing structural design. Let's go forward. Okay, this is just a quick overview of Building 7. I think everybody probably here has seen this. It was a very large building, had 75% of the volume of the Empire State Building, which might make you realize how big this building was. It was trapezoidal. There was a substation on the first 2 floors in the back, on the north side. And you can see a lot of people say it was built over the substation. It was actually built through it. The foundation caissons and the columns go through it. And it had 82 columns, 24 interior, 58 exterior. This gives you another idea how big the building is. You're looking down the north interior side. You're only seeing half of the building between these 2 pictures. One's on the longitudinal north side, and the other's on the east interior side, east side. Here's I like this picture because the NIST report tries to say that Building 7 experienced a lot of damage from the North Tower, which was the second to fall. In the picture, you can see a large piece of debris coming off the North Tower, and it's quite a distance from Building 7. That large debris would not fly that far, 350 feet. And here you can see the light debris zone, heavy debris zone. It did suffer some damage, very light. And here's NIST, the NIST model of it, and then down in the lower left corner, they say 7 columns were severed. In order to sever those columns, each one of those columns would have to be hit by 10,000-pound loads in a sweet spot. And I'm not the only one saying that. Dr. Robert Corll has done an analysis on that also. NIST has no evidence for this. They say in their transcript of their initial brief, they did it with and without debris models, and they said it's probably somewhere in between, which when you sift through that, you're going to realize that they don't have evidence for all those columns being severed like that. And this is what they say happened. This is a little more detailed. We're trying to get you in. I realize you don't need to remember all these details. Realize we're here for you, and the consultancy can take place later on. I'm just going to go through it so you get an idea of what's happening. In the northeast corner, which is the upper right and the upper figure, there's 5 beams in red. They're saying push that girder to the left off its seat at column 79, which is the corner core column, you'll see. And down in the inset, you'll see where they try to show the girder in the seat. They say the girder is pushed off its seat so that the web is past the seat, and that the load is just on the flange, which is only the thinner part of the I-beam, and that can't handle the load, and it folds up and fails. There's a cascade of floors, leaving this column unsupported, and I go through that. Ultimately, it causes the floors to fail. They say it goes down 8 floors, and that leaves it unsupported from the north. And then they say that the girder connections coming in from both the west and the south also failed due to thermal expansion, causing column 79 to buckle, precipitating an east to west interior collapse. The entire interior collapsed, and then we had an exterior shell, which on the lower right, you're going to see that's the NIST model. That's the without debris model. The with debris model has a little less deformation, but it's similar. And then we don't see that kind of deformation. You saw, Richard showed you the video of the collapse. You don't see that kind of deformation. And this is a little more detail. That girder, if it had shear studs, would be much harder to push off its seat. NIST denied there were shear studs. This fellow in the upper left, his name's John Salvarinas. He was an engineer for Frankel Steel, who was the erector of the building in the 80s. He wrote a paper that he submitted to the Canadian Structural Engineering Conference in '86, and he said there was typically 30 shear studs on that girder. NIST denied that, said he gave no reference. It turned out there was a lawsuit in the appeals court, U.S. Circuit Court of Appeals, against Larry Silverstein and World Trade Center 7 Properties, and one of the, it was admitted that there were 30 shear studs on that girder. So NIST lied about those shear studs. Whoever wrote the NIST report lied, I should say. And this is just giving an idea of how hard it is to get that girder to walk off that seat. They have to heat the beams. They're pushing it to 600 degrees centigrade. That's a little over 1100 Fahrenheit. And you can't expand more than 5.7 inches. Well, they said in the report that the girder seat was only 11 inches wide because you can only get 5.5 inches of expansion. Turned out when the drawings were released 3.5 years later, this seat was 12 inches wide. That's only one. What do you hear more? They don't consider any expansion to the east. All expansion goes to the west in their scenario. That doesn't happen in real life. They also omitted, one thing we found out when we got the drawings, they omitted these stiffeners that you see highlighted in red in the lower left. The upper left is the depiction in the NIST report. You don't see those stiffeners that you see in the two lower wireframe images or figures. There's a solid model on the left. You can see those stiffeners. The upper right is the NIST figure in the NIST report, no stiffeners. Now those stiffeners are very important because they make that flange about 85 to 90 times stronger than it would be without them. Okay, it's sort of, if you remember when you were a kid and you had the 12-inch ruler, when you bent it like a diving board, it was easy to bend. Turn it 90 degrees and try to bend it across the stiff part. It doesn't work. That's what the stiffeners do. They took them off. And Dr. Pepper wrote a letter to the U.S. Commerce Department, and we documented this and asked them about it. And they said, we stand behind our work. We don't agree with your assertions. That was it. Surreal. Here's a picture taken during construction, and the inset, you can see the stiffeners on that girder, down in the lower left. This is a finite element analysis showing you how low the stress would be. Okay, you can see that you're looking from the back of column 79 there. Don't worry about it if you don't have your bearings on it. The stress is extremely low, and even if the girder was heated to 500 or 600 degrees, it would still have a very significant factor of safety. This is the AREP report. This was done for that the lawsuit in the Circuit Court of Appeals, and they show something that's ignored. That if you look on the right side, you're going to see column 79. It was an I-beam H-column type of configuration and had 2 by 26 inch side plates welded to it, and that's what's sticking out. Well, the girder, because it's heated, is going to go against the column flange, and it's going to get trapped by that side plate. It can't get past it, and that's what the AREP analysis shows, and that's honest. And it also shows those other girders coming in from the west and the south are stable. It says it right in their report. Okay. Another thing the AREP analysis did was give us an opportunity to look at this. They said the floors cascaded downward, or when the girder fell, it hit the next floor down and sheared the girder seat on that, and there was a cascade of floors. The AREP analysis, it turned out there was an error in it. The fellow gave an infinite stiffness. He used a point load. And in reality, when that girder hits, it's going to deflect. When something deflects, it has a lot less of a shock load. It can't break through the next floor down. I did an analysis. I'm not going to walk you all through this. I'm just showing you there was detailed analysis done. You determine the natural frequency, you can determine the stiffness of the girder and beam assembly, and lo and behold, it takes 632,000 pounds to shear the seat on the girder below. The impact load, even though it's 46,000 pounds of weight, it's going to hit it with about 200,000 in impact. It's an amplified load. It's nowhere near the 632,000 needed to shear that seat, and we can prove this. So the false assumptions used in this World Trade Center 7 report, just to summarize, to make their collapse initiation hypothesis seem plausible. No shear studs on the girder, and that has to have been a lie. And if not a lie, a great deal of negligence. The girder seat they are saying was 11 inches, was actually 12, and that's very suspicious because they could only get 5.5 inches of expansion. Why would they change that? They had all the expansion going to the west. They left off the girder stiffeners, and when we talked to them about it, they says, "Oh, well, our analysis said we didn't need them." How could it not need them? And they said the thermally expanded girder could move past the column 79 side plate. Actually, they ignored the side plate. That's what they're saying. That's their assumption. The west and south girders, column 79, had their connections broken. That's very interesting because on the 10th floor, there's no fire. So you need about six floors to be unsupported on this column 79 to have it start to go into buckling. Well, in the middle, there was fires on floor 7 to 9 and 11 to 13. There's none on floor 10. It could go 4 floors without support. They try to say that the girder, 2 stories up, 26 feet up, pushed on column 79, pushed it to the east, and broke the connection that was still cool under floor 11 because there's no fire on floor 10. Another thing they proved, they provide no analyses. Again, they don't provide analyses for these things. And of course, the northeast floor failure cascades, that's impossible, and that can be proven. Just real quick, I just want to show, at the beginning, you can see the east penthouse collapses itself first before the rest of the building. And a lot of people try to say, well, it was taking 16 seconds to collapse. That's not really true. It turns out the east penthouse had to go down. It was a separate and distinct event. And the reason I'm going to say that, this is a NIST on the right. NIST removed column 79. They show a kink in that penthouse. On the left is the actual photo. That's only indicative of a failure below, not how far down. Doesn't mean it's at the 13th floor of the 47-story building. And it looks like because you can only see window breakage 15 stories down, and the shock wave goes top to bottom. This was happening at 13th floor up. You wouldn't see a shock wave just from top to bottom. And the windows would be broken on more than just the roof down 15 stories. The daylight's only visible in the upper windows, and it's a 144-foot wide building, so you'd see a lot more daylight there, at least a few floors. This is a video, but I don't really need to show this. But
I got it.
All right, you see how the dust only comes out when the whole building comes down? And this is trying to say the whole east side interior had collapsed first and then went to the west. If that had happened, you'd see dust coming out of the windows. So it can't be that that whole east side collapsed. In addition to the other things, like I said, the shock wave is top to bottom. You only get windows broken from the roof down 15 stories. So let's go to the next slide. Yeah. Okay. Sure I will. Yeah. A little slower? Okay. All right, I will. I understand. I realize, Dan, that it's a lot to take in at one time. I'm not asking you to do that. I think what you have to realize is just be aware there's serious problems, and we're here for you, and we can get it, imbue you more thoroughly later on. Okay, what I'm trying to say here, this is also a video. Richard, if you can show this real quick. Okay, you see all 4 corners come down. And Richard will show you a video. This is a quick video. They all come down simultaneously. It's a symmetric collapse. And what the NIST wants to say is this was a hollow shell after the whole interior collapsed, and that the collapse started on the southwest corner where that debris damage was, and the columns buckled sequentially over 2 seconds. Now, 2 seconds of gravitational acceleration is like 64 feet. Do you think you see a difference of 64 feet between one corner and the next? I don't. Okay? So if we go back to the text, Richard, I just want to say, that's it. Okay. So the east side interior, if they had collapsed 6 seconds before the full building, you'd have seen significant deformation. Those columns could only stand 16 stories unsupported laterally because then they start to buckle. It's too slender. You don't see any deformation in the real collapse. In this model, you do. Okay, so the video shows that the columns failed simultaneously over the whole building, not sequentially from one side to the other over a 2-second time period. That can't occur due to a progressive interior collapse east to west. What's happening is the entire core, 24 columns, have to be coming down at one time, or starting in the center within a fraction of a second, all 24 core columns. That'll pull the exterior columns in simultaneously over the whole building. And when they're slender, like if 8 stories are taken out of the core, you're going to have 9 stories or 117 to 120 feet of slender columns in the exterior being pulled in. And what happens is called snap-through buckling. They just give up the ghost. And that's what happened. Okay, and I think you're going to hear from David Chandler later on. He's the one that forced the admission that it was in free fall.
Thank you very much, Tony.
Okay.